The function g is defined below. Find all values of x that are not in the domain of g. G here is a rational function. There's a polynomial in the numerator and there's a polynomial in the denominator. We are very concerned with the denominator. Let's check it out. G of x is equal to x minus 3 over the quantity x plus 3 times the quantity x minus 3. Right here, this tells us a lot of information. This says that x plus 3 times x minus 3 cannot equal 0. We do not want 0 in the denominator. So x plus 3 can't be 0. And x minus 3 can't be 0. That means x cannot be negative 3 and x cannot be 3. That would answer the question. Let's answer the question just to be very, very clear. The values of x equals negative 3 and x equals 3 are not in the domain of G. There is a second and third part. So there are more examples. There's example B and example C. Find all values of x that are not in the domain of H. Once again, you tackle this problem by factoring the numerators. Well, I don't even need to factor the numerator. We just need to factor the denominator, because the domain of a rational function has everything to do with the denominator and not the numerator. The denominator here is x plus 6 times the quantity x plus 7. Yeah. So once again, x cannot equal negative 6, and x cannot equal negative 7. The values of x equals negative 6 and x equals negative 7 are not in the domain of H. Now we have a different function, different h of x, and we're going to start off in a very similar manner. X squared minus 16x plus 64 cannot be 0, right? I should have wrote that up here as well. We could factor this. This is a perfect square trinomial. So x minus 8 quantity squared cannot be 0. That means x minus 8 can't be 0. X cannot be 8. The value of x equals 8 is not in the domain of H. It's better to write a complete sentence for this particular problem just to make sure you understand how to answer the question.